Hello everyone, welcome back to Let's Unbound. In this AP Precalculus series, we are in section 1.10, Rational Functions and Poles. This is a very important topic, and in the previous video, I gave you a basic idea about what the holes are then and there. Today we are going to dig deeper, step by step, so keep your pen and paper ready and make sure to watch it from the beginning till the end so you don't miss anything. And remember, if you have any doubts, questions, or even if you found a different approach, drop them in comments. We are glad to help you out here. All right, let's get started with 1.10. Okay, what is holes in a rational function? Actually, it's a kind of a discontinuity. A smooth curve will get disconnected by a hole. That's simple. And then after that hole, it immediately emerging. Okay. Now, a hole occurs when a factor cancelled out from both numerator and denominator. Okay. So in many problems, when we simplify, some factors cancelled out. They will produce a hole. It represents a single point missing from a graph. For example, like this. Okay. Exactly here, the function is not working. It has some problem. Now, what we can infer from, if x minus a is a factor that present in numerator and also in denominator, then you can see there is a hole at x is equal to a. Just equate to 0, you will get x is equal to a number and hole. And always we represent the hole by, because it's an exact location, right? So you have to tell us a coordinate. So a comma what? Okay, for finding y coordinate, cancel out the common, right? And in a simplified function, you should substitute and find the answer. F of x is original means fs of x, and in the simplified version, you have to plug in. What if you plug in without simplifying? You will get an indeterminate form like 0 by 0, something like that. Okay, so always using simplified. Very simple. Now, holes can be represented in limit form. Okay, if it's a hole, then limit exists. Left side limit and right side limit will give you the same number. So limit x tends to the left of the number will be equal to limit extends to the right of the number. Limit exists and it will be equal to f of a, of course, which is the simplified version, not the original function. Got it? Now, poles and continuity. Yes, poles is kind of a break, but a function is continuous at x is equal to a. If all the three are true, it should be defined, limit exists, and that limit should be equal to that f of a value. Yes, but holes we can treat it as a removable discontinuity. Yeah, it's a discontinuity, but removable. What can I do? From the function, you just remove that point. Okay, so for example, if you got a hole at x is equal to 2, from the entire domain, you just remove this. Then it will be continuous with its own domain. Right? So this is the continuity definition. And if there is a hole, you can remove it. That is removable discontinuity. Now, multiplicity of factors in rational functions plays an important role. A quick recall, what is multiplicity of a factor? Our rational function is made up of numerator polynomial, denominator polynomial, right? And it can be factorized. So it might have x minus a power m, x minus b power y, okay, sorry, b, something like this. And again, x minus a power n, x plus b power s, something like this. So when you find a hole, like you will say this get cancelled and we got some x minus a whole power m minus m, the resulting stuff. This is the multiplicity. We call it as net multiplicity, not alone. If you find both the numerator and denominator, just subtract them and find the net multiplicity. And we will see the rule, how this multiplicity works in describing the graph's behavior. Okay. So if x is a 0 or a vertical asymptote, multiplicity affects the graph's behavior at that point. Let's see how it works. If you got an even multiplicity, I'm always talking about the net multiplicity when I talk about rational function. Okay. Factors appears an even number of times. The graph touches the axis. So the graph will touch the axis or asymptote. Okay. But does not cross. Odd multiplicity, the graph crosses the axis or an asymptote. That's simple it is. Okay. Now, multiplicity of factors in rational function. Okay, what about the powers? Numerator and denominator. In both the places, particular factor present, and their degrees also. The multiplicity also equal means it's a pure whole. Okay, because the factors cancels completely. If your numerator wins, then whole and an asymptote, because one extra factor will be there in the denominator. If your Wait, what? Actually, here denominator wins, right? Yeah, denominator wins. And next is your numerator wins. Then numerator will have some extra, right? And then it's a whole plus 0. That means a whole present in x-axis. Okay. This is whole present in vertical asymptote. And it's a pure whole. This is how we will compare the multiplicity and its power. Okay, so that's a simple, crisp overview. If you find something difficult, just pause the video and go back and rewatch it, then come to the problem solving with a fresh mind, right? Here in question 1, let f of x be this. Identify the whole and vertical asymptote. Find the coordinate of the whole. Okay, first you have to factorize, like make it simpler. This will get cancelled. You got x plus 1 by x minus 3. The cancelled out factor is x minus 2 equals 0, which gives x is 2. This is a whole. So whole at x is equal to 2, we need the coordinate. How will you do this? Here you need to plug in f of 2 equal 2 plus 1 by 2 minus 3, which is 3 by negative 1, which is minus 3. So whole at 2 comma negative 3. Right. And next one is vertical asymptote. In the simplified version, what is left out denominator? Set that to 0. So vertical asymptote is x is equal to 3. That's simple. We find the wholes, the coordinate of the whole, and also vertical asymptote. One whole and one vertical asymptote. Right? Now moving to question 2. Identify the whole and vertical asymptote. Describe the behavior at the whole. Is it a 0 asymptote or just whole? Okay, so what is common thing? This one. A numerator wins. For of course, it's a whole, right? Numerator wins here. So if numerator wins, it's on x-axis because numerator can become 0. So numerator wins when x is equal to 2 is a whole and lie on x-axis and a 0 whole. Whole plus 0. Right? And you can find that 2 comma. Of course, this will make the function 0. And how to find the coordinate, you should simplify this. So simplified version is x minus 2 into x plus 1 by x minus 3. If you got this whole plus a 0, the coordinate for sure it will be 2 comma 0. Okay, because it is on the x-axis. Right, and vertical asymptote. In the simplified version, what is left over? X is equal to 3. So vertical asymptote is x is equal to 3. That's simple. One asymptote, one whole, and its behavior is it's a 0. It's a kind of a 0. Right, and question number 3. Okay, here's a graph for you, the reference. So when you graph that particular function, it will be something like this, whole at 2 comma 0. It is also on the x-axis, right? And vertical asymptote is over this dotted line. X is equal to 3. We have a vertical asymptote. That's simple. Now question 3, kind of lots of factors here involved. It will be a good practice. Identify the whole and asymptotes again. So I might got more than one whole. This is having like same factors. So x minus 1 equals 0 will give you x is equal to 1. That is a whole. Okay. What kind of whole? Is it a 0 whole or it's a asymptote whole or a pure whole? Numerator wins. So it's a 0 whole. Okay, then you can write the coordinates 1 comma 0. Simple. So it's a whole plus 0. Now, x plus 2 also cancelled out common. X plus 2 equals 0 and x is equal to negative 2. This is also a whole plus 0. Okay, so minus 2 comma 0. And this is wholes part is done. Vertical asymptote. What is left over? So this will be cancelled. This will be cancelled. Leftover denominator will be x minus 4 and it will be x is equal to 4. Now coming to B. What are the multiplicities? How do they affect the graph? Simple. So x minus 1 multiplicity, net multiplicity is 2 minus 1, which is 1, which is odd. So odd multiplicity means the graph, it will cross the x-axis. Of course, it's on the x-axis. So will it cross or bounce back? Okay, 0 happened. Will it go down or it will cross? That's the question. So odd means it will cross, even means it will be bouncing back. So odd, so cross x-axis. Now coming to this, x plus 2 whole power 3 minus 2 equal 1, again odd. So it will cross x-axis again. This is the behavior, and yeah, this is how the multiplicities affects the behavior of the graph near the holes, right? That's simple. And I have a bonus question as usual here. F of x is given, identify holes, vertical asymptote, state the multiplicities and describe the behavior. Okay, very simple. Odd means crosses, even means touches. And also find the coordinate of the hole. Basic thing. So I hope this might be clear to you. I will be meeting you next video very soon. Until then, keep learning, keep practicing. If you want to join the student community of Let's Unbound, you can scan the QR code given here. Stay curious. Let's meet in next video.